Hello. Good morning to one and all. Moving with us. Hello. Hello. Good morning. Good morning. Hello, good morning to Ananda. Hello, I request Bharti Chirla Madam to stop screen presenting. The session is about to start. Bharti ma'am, could you please stop sharing the screen? I request Bharti ma'am to stop sharing the screen.
Deepthi, start Chinana.
A blissful morning to the respected dignitaries and faculty members. Hope you all are staying safe. I extend my hearty welcome to each and everyone. Myself, Sridipti, pursuing third year from the Department of Triply from SV College. Welcome to the short-term training program on research trends in renewable photovoltaic system and its research challenges. Prayer. Prayer is an action. It is the process of talking with God with energy in order to achieve a purpose. So let's begin this webinar by seeking the blessing of Lord Almighty with a prayer song. Varamulano sage vinayaka ma pujalanduko gananayaka. Varamulano sage vinayaka మా పూజలందుకో గణనాయక. నిరతము నిన్నే కొలిచెదము మీ నామమునే తలచెదము. నిరతము నిన్నే కొలిచెదము మీ నామమునే తలచెదము. పార్వతీపుత్ర వినాయక పరమ పవిత్ర గజానన వరములను సగే వినాయక. మా పూజలందుకో గణనాయక. Thank you. Once again, welcoming you all. I request everyone to please mute your microphone and turn off your video. Now, I take the pleasure of inviting our dynamic, hardworking, and supportive true leader, Dr. N. Sudhakar Reddy sir, Principal of SPCE.
Thank you, Deepthi. I apologize for Principal sir today having some meeting, so he's unable to join the meeting. But I'm sure that he will address the gathering by afternoon. So I'll take the privilege to invite all the participants. Good morning and warm welcome to all the participants who attended earlier phase 1 STTP, and this is phase 2 of the same STTP. As we have taken the so many feedbacks from the earlier attended participants, based upon their valuable feedback, we introduced some of the concepts like soft computing, restructured power systems, and nature-inspired algorithms in this particular STTP. And coming to the next phase, we will be discussing on smart grids. So please maintain the continuity. And it's a time to invite our chief guest as well as today's speaker, Professor J. Srinivasul sir. Welcome, sir.
Thank you, Bhargav.
Sir. I would like to, sir. Thank you. I would like to say one word. Actually, we have a very short span of time to invite all the resource persons, but we are in a search of to invite the first speaker. So sir has immediately accepted our invitation. It's a great honor for us, sir. From the bottom of my heart, I thank you on behalf of SV colleges as well as my department, sir. Thank you, sir. Deepthi, I request please go through the sir profile.
Yes, sir. I consider it a great honor to speak about our chief guest, Dr. J. Srinivasalu garu. Dr. J. Srinivasalu garu is presently working as a senior assistant professor and a training and placement officer at JNTUA College of Engineering, Anantapur. He has completed BTech in MITS Madanapalli, MTech in JNTUA College of Engineering, Anantapur, and PhD in JNTUA University, Anantapur. He has total 11 years, 6 months teaching experience. He has published 15 international journals and presented 4 national conferences. He has guided 15 PG students. He acted as 8 times as a judge for technical symposiums. He has received various administrative positions like training and placement officer, coordinator of career and counseling cell, students coordinator, nodal officer. He is a member of IEEE and IAENG. Sir has received Best Outgoing Student Award during his BTech. Welcome, sir.
Thank you, Deepthi, for introducing me to the participants. So, good morning to all of you. Initially, I thank Mr. Sudhir, head of the department, electrical department, and I thank principal of SV Engineering College, Professor Sudhakar Reddy sir, for giving me the opportunity. Well, Sudhir, shall we start the session?
Yes, sir. Yes, sir. Please go ahead, sir.
Sudhir, are you able to see my screen? Hello.
Yes, sir. Visible, sir.
Yeah.
Yes, sir. It's visible, sir.
Thank you.
Yes.
Yeah. Good morning to all of you. Well, in today's session, I want to discuss about uh, restructured power systems, and I want to make you aware about restructured power systems and its concepts and its research challenges. Well, before going to discuss restructured power systems, let us recollect our traditional power systems called as vertically integrated power systems. So few decades back, we have a power system called as vertically integrated power system. It means that generation of electrical energy, transmission and distribution all are controlled by one entity, and it is called as one utility, and which is nothing but government. And many engineers identified that many drawbacks are there with respect to vertically integrated power system, and hence, with the formation of Federal Energy Regulation Commission, they want to change the regulations of the power systems, and that's why it is named as deregulated power systems. And they want to change the structure of the power systems. That's why it is also named as restructured power systems. So, coming to the vertically integrated power systems, many major drawbacks are lack of competition. So that means there is a monopolism in the traditional system. Why? Because customers don't have alternatives for purchasing power. So government is the only alternative, and generation, transmission, and distribution, all three sectors are controlled and governed by only one entity. Hence, there is no competition in the electricity market. Hence, that is a competition is a major drawback, and not only that one. Nowadays, due to advancement in technology and as well as in terms of industries, in terms of uh, whatnot, whatever you consider. So nowadays, due to advanced technology, people doesn't tolerate uninterrupted power supply. So continuous supply is essential nowadays for running their applications uh, and for doing their business activities in their day-to-day life. Hence, continuity supply is also a problem in the traditional system. Why? Because if any generator outage takes place, then obviously it takes some time to restore normal operating characteristics. Until that, customers should wait for the continuous supply. So that means satisfactory levels of the customer is very important nowadays. So that's why with respect to competition, with respect to continuous supply, with respect to reliable electricity, and one more important parameter is least cost generation. Sorry, 1 minute. So due to least, but sorry for the disturbance. So in vertical integrated system, major drawbacks are competition, continuous power supply, and satisfactory levels with respect to the customer, and as well as least charge with respect to the electricity consumption. So based on all these things, many engineers thought to create new market where they mainly concentrate to improve the competition such that customer choices will be improved based on the levels. So these are the topics I want to discuss in today's class. So, well, coming to the, as I said earlier, vertically integrated power system is nothing but generation, transmission, and distribution all are controlled by one entity uh, that is called as vertical integrated power systems. And so that means uh, utilities, this vertical integrated monopoly utilities have practiced monopolism in terms of controlling, in terms of selling, in terms of transmission services provided to the customers. And all these things are controlled by only vertical integrated power system. Hence, there is a scope to practice monopolism in this system. And so if you compare airlines, telephone industries, and natural gas industries, their competition is more, and what monopolism concept is not possible in that way. So based on that, by considering all these industries, people thought to change the regulations in electricity market also. So that's why many engineers' efforts power system is reshaped into the restructured power systems and deregulated power systems. In this restructured power system, the main task of the generation, transmission, and distribution will remain same as before. But however, to obey the rules and the regulations formed by the Federal Energy Regulation Commission, and such that all these rules framed by the FERC for improving competition and as well as for improving open access to the all users, such that consumers can understand when will the electricity price is high and when will it is low. Accordingly, they can change the consumption pattern such that they will save some money. So a competition is guaranteed by establishing a restructured environment in which customers could choose to buy from different suppliers and change suppliers as they wish in order to pay market-based rates. The main objective of electric power restructuring is to significantly reduce the cost of power charged to the small consumers especially. So these rules gave birth to the new classes of entities such as pool, which manages information independent of power generators, retailers, and users, and does not own any power facilities. So that means due to these rules based on Federal Energy Regulation Commission, these rules gave birth for new markets like pool, bilateral, and hybrid markets. And in addition to that, many new terms are created for coordinating and maintaining secure operations system. New terms are created. They are nothing but ISO, Independent System Operator, Power Exchange, Scheduling Coordinators, bilateral contracts, transmission congestion contracts, locational marginal prices, bidding process, auctions, capacity rates, market power, standard cost. So like this, many new concepts are created, and it is essential to understand all these concepts and what are the functions and necessity of all these concepts, such that we can understand the restructured power system effectively, and we can understand its challenges such that we can try to solve those challenges in the field of power system. So before choosing any model, we should always debate who will maintain the control of transmission grid, what types of transactions are allowed, what level of competition does the system guarantee. So based on these three questions, people try to classify restructuring models in three classes. One is pool model, bilateral contract model, hybrid model. So coming to the pool model, which consists competitive, power providers as obligated members of an independently owned regional power pool, vertically integrated distribution companies, vertically integrated transmission companies, and a single separate entity. So, who is nothing but independent system operator and who is responsible for establishing bidding procedures, scheduling and dispatching generation resources, acquiring necessary ancillary services to assure system reliability and administering the settlement process and ensuring non-discriminated access. That means fair and open access to the transmission grid. So that means pool core comprising generators, transmission, and as well as distribution companies. And in addition to all these three, one non-profit entity who is nothing but independent system operator and who is taking to responsible for establishing bidding procedures, scheduling and dispatching generation resources, and sometimes he can also provide ancillary services for system reliability. And he ISO can also take a settlement process, and of course, it can always try to provide fair and open access to with respect to the transmission grid. So Poolco does not own any generation or transmission components and centrally dispatches all generating units within its service jurisdiction of the pool. So Poolco controls the maintenance of transmission grid and encourages an efficient operation by assessing fair fees to the customers and distributors to cover its operational expenses. So in Poolco, sellers and buyers submit their bids to inject power into and out of the pool. So sellers and buyers both can submit their bids for purchasing power and as well as for selling power. And accordingly, so if a power provider bid too high, it may not be able to sell power. On the other hand, if buyers compete for buying power and if the bids are too low, they may not be getting any power. So that means based on the market conditions, sellers can and buyers can fix the price with respect to selling power and as well as with respect to purchasing power. And too much high price with respect to sellers may not possible to sell the power, and too low price with respect to buying power is also not possible to get power from the market. So in this market, low-cost generators would essentially be rewarded. Power pools would implement the economic dispatch and produce a single price, nothing but spot price for electricity, giving participants a clear signal for consumption and investment decisions. Winning bidders are paid the spot price that is equal to the highest bid of the winners. Spot market is where market generators are paid for the electricity that they have sold to the pool, and market customers are charged for their electricity consumption. So for generators, amount will be paid for selling the power, and as well as customers will pay amount to the used power. So market dynamics will drive the spot price to a competitive level that is equal to the marginal cost of most efficient firms. So here in Poolco, generators submit their bids for selling power and as well as customers submit their bids for purchasing power. And ISO can receive bids from both suppliers and as well as, from generators and as well as from customers and as well as from transmission customers. So based on all these bids, ISO can take care to arrange their bids and they can create market clearing price such that they can improve the competition levels in a fair manner. So ISO in a Poolco is independent of transmission and generation owners and for operating the transmission grid. So competitive generators submit bids to the ISO on a day-ahead basis, specifying the amount of energy available, price, and delivery points. While distribution company do the same for load size. So ISO, based on submitted bids, forecast the short-term regional energy demand and dispatches generation in the region to balance generation with the load and maintain reliability. So here in this pool model, generators submit bids for purchasing for selling power, and as well as customers bid for purchasing power, and as well as transmission customers can bid for selling their transmission services, and of course few other entities will also join for selling their ancillary services like reactive power supply, voltage control, and frequency control, and reserved power, etc. So all these things will be coordinated by one non-profit entity, and which is independent among all these entities, and who is nothing but ISO, and who is taking responsible to schedule, forecast the load demand, and based on that, he can try to maintain balance between generation and demand, and accordingly, it dispatches generation to the customers, and such that it also maintain system security and as well as reliability. And you just see in the olden days, here two pictorial representation of it. Figure 1 represents that demand is variable one, but cost is fixed by the power system is saved. So that means irrespective of the demand or irrespective of the consumption, they are charging same. But due to the price signals, when you consider, so if customers should, if customers are able to see and understand the price signals in the market, then whenever price signals are high, then customers can set down their unwanted and unimportant loads during high price signals, such that they will be charged less and they will be saving some amount with respect to the electrical consumption. So in the second figure, response of a demand to price signal. So if you just see the dotted lines are nothing but customer demand, and the thick line is nothing but market-based price. So when price is low, then consumption is more, and when price is high, consumption is less. So accordingly, so that means price signals plays vital role, and it gives greater input for the customers, such that customers will be set down the unwanted and unimportant loads during high market-based prices. So another model is bilateral contracts. See, in Poolco, and compared to, when you compare Poolco and bilateral contracts, in Poolco, so generators, customers, transmission companies and distribution companies and customers, just they can bid their requirements, maybe in terms of quantity, how much they want to sell, and what is the price, and similarly how much they want to purchase, and what are the locations, and all those data should be submitted by the customers. Customers may be, participants may be generators, may be consumption customers, or maybe transmission customers, etc. So, and ISO should take care all the bidding process, scheduling and dispatching process, and maintaining system security and reliability concepts, and even they can settle accounts after the market also. So that means ISO is taking more responsible, and only ISO takes entire responsibility with respect to bidding, with respect to scheduling, with respect to dispatching, and maintaining system security and reliability. But coming to the bilateral contracts, major difference between Poolco and bilateral market means customers can directly negotiate with the generators in this market. So large customers can directly negotiate with respect to price for the required amount with the generators itself. So that possibility is available in bilateral contracts, and that's why ISO role is more limited, and buyers and sellers could negotiate directly in the marketplace. This model permits direct contacts between customers and generators without entering into the pooling arrangements. Of course, by establishing fair access that is nothing but non-discriminatory access and pricing rules for transmission and distribution system. Direct sales of power over utility transmission and distribution are guaranteed, and wholesale suppliers would pay transmission charges to a transmission company to acquire access the transmission grid and pays similar charges to a distribution company to acquire access to a transmission grid. So any two contracted parties would agree on contract terms such as price, quantity, and locations, and generation providers would inform the ISO. So feasibility is created that direct negotiations with respect to the customers and generators is possible in bilateral markets, but once after finalizing the agreements with respect to the customers and as well as generators, and they should inform price, quantity, and locations, and according to the agreement, whatever they discussed, and all those information must be provided to the ISO, such that ISO, based on the data, ISO can generate hourly generators would be dispatched. So ISO would make sure that sufficient resources are available to finalize the transactions and maintain the system reliability. So here, sometimes for maintaining system security and reliability, ISO can take care decreasing decreasing the power with respect to the customers also. So that means if whenever any generator is outaged, then for maintaining balance between generation and demand, ISO can take care certain steps for maintaining balance between generation and demand. So to maintain reliability in real time, suppliers will supply incremental and decremental energy bids to prevent transmission flow congestion. Here, a cost-based transmission pricing would provide a non-discriminatory, nothing but open access to transmission and distribution grid. See, here, power system, if customers know the transmission price signals and transmission capacity clearly, then they can, so transmission capability and its issues plays a vital role in providing competition. So that's why transmission information must be visible and open to all the customers, irrespective of their affiliated organizations. So that means, suppose if a transmission customer have its own affiliated company, then he can share information, critical information to that affiliated company, and he can hide that information to others. That means that is not fair, and such that some customers will be affected severely. So that's why you should provide non-discriminatory access to the transmission and distribution systems. So that one will be taken care by ISO in these structured power systems. And last one is hybrid model, and which is a combination of both full core features and as well as bilateral features. So here this model combines various features of the previous two models. The hybrid model differs from the pool core model as utilizing the power exchange is not obligatory, and customers are allowed to sign bilateral contracts and choose suppliers from the pool. So that means a customer can directly negotiate like bilateral by using bilateral concepts, or a customer can choose to purchase power or sell power through the pool also. So both the features are possible in this model, and the pool would also serve all participants, buyers and sellers, and who are not choose to sign bilateral contracts. So hybrid model is very costly to set up because a separate entity required for operating power exchange and transmission system. So power exchange is a non-profit and independent entity, and which is also somewhat similar to the independent system operator. But here power exchange will take care large contracts in the markets. So we will discuss few more important points power exchange in the coming slides. So, well, independent system operator. I hope all of you understand. Yeah, please tell me.
So sorry for the disturbance, sir. Sir, Bharti madam is presenting,
Sir,
so it's stopped, sir. Can you present again, sir?
So at which point, which slide it was stopped?
Just now only, sir. Just now only she has been presented.
Okay. Okay. Okay, please. Carry.
Yes, sir.
హలో సార్ క్లాస్లో ఉన్నాను సార్, మళ్ళీ కాల్ చేస్తాను సార్, అర్జెంట్ ఏం లేదు చెప్పండి సార్. లేదు సార్, జనరేషన్ సిస్టమ్స్ సార్. ఓకే సార్. సరే సార్, ఓకే సార్, సరే సార్. 25th ఆఫ్టర్నూన్ నుంచి వస్తాను సార్, క్లాస్ ఉంది రోజు మార్నింగ్. ఓకే సరే సరే. మేడం ఏదో భారతి మేడం స్టార్ట్ చేసిందంట, అంటే ఇప్పుడు స్క్రీన్ కనిపించలేదా? ఓకే ఓకే, సో కెన్ ఐ కంటిన్యూ? ఓకే. హలో
Sir, it's visible, sir.
కెన్ ఐ కంటిన్యూ?
Yes, sir. You can continue.
Sorry for the interruption. So, as I said earlier, independent system operator, he is very important in this structural power system, and who is non-profit and independent entity, and who is taking more responsibility for providing open access to the transmission system, and as well as who is taking care bidding procedure and scheduling and dispatching procedure and maintenance system and security and reliability of the system, and who is also responsible for maintaining balance between generation and demand. Well, during the last few years, competition in the generation sector has increased due to growth in the number of power suppliers, while the open access to transmission system was more limited. Why it was more limited in the vertical integrated means all three major sectors are governed by only one entity, and that's why transmission access is not possible. So that's why that is also one of the shortfall of the vertical integrated system. Now it was considered that shortfall want to be clear in the restructuring process. Limitations came as vertically integrated utilities favored their own generation when transmission was congested, and limitations arose by preventing other utilities or suppliers full access to the term. As I said earlier, transmission company can share their critical information during congested to the own affiliated organizations or entities, and they can hide some critical information to the other customers, such that customers will not get paid information from the market. Hence, that is the limitation of vertically integrated grid systems. Unfair industry practices generally impacted the growth of the competitive generation market, where motive forces for the FERC to order transmission owners to provide other parties and open access to the transmission grid. So, in this restructured system, FERC want to provide open access to the transmission grid. So, however, independent operation of the grid was not guaranteed without an independent entity, the so-called independent system operator. So an ISO is independent of individual market participants such as transmission owners, generators, distribution companies, and end users. So the basic purpose of an ISO is to ensure a fair and non-discriminatory access to the transmission service and auxiliary service, maintain the real-time operations of the system, and facilitate its reliability requirements. So the primary objective of the ISO is not dispatching or redispatching generation system, but matching, as I said earlier, ISO should be responsible to maintain supply and demand, so for maintaining reliability. And ISO should control generation to the extent necessary to maintain reliability and optimize transmission efficiency. So ISO is mainly responsible for maintaining system integrity by acquiring resources necessary to remove transmission violations, balance the system in second-to-second manner, and maintain system frequency at an acceptable level to retain stability. So, in emergency conditions, the system reliability is an absolute responsibility of ISO, and the ISO has the authority to commit and dispatch some or all system resources or components. The ISO has ability to call for increase or decrease in generation and to curtail loads to maintain system security. So, in this pool market or in this restructured markets, ISO is fully responsible for dispatching and redispatching generation, as well as scheduling and redispatching generation, and maintaining balance between demand and supply, and even sometimes ISO can provide auxiliary services like reactive power supply, the voltage control, voltage regulation, frequency control, and reserved power, and all these things. So auxiliary services supplying, and not only all these things. Sometimes ISO have ability to call increase or decrease in generation and to curtail loads to maintain system security. So an essential task of the ISO in all restructuring model is mitigating transmission constraints. So generally, between generation and customers, one of the main important part is transmission system, and there only many constraints will be arising. So that's why essential task of ISO is to take care, to mitigate, and to eliminate transmission constraints like congestion and voltage violations and frequency deviations, etc. So let us see one example how an ISO can play a vital role when there is a mismatch between generation and demand happen. So whenever any mismatch or imbalance between generation and demand takes place, then ISO used to bring reserved power, available reserved power into the market, and if still mismatch is there, then ISO can curtail reserve loads who are participated in reserve process, and such that it is trying to maintain balance between generation and demand. So let us consider a small example. Let us consider hydroelectric generator and who is having capacity 30 megawatts capacity and who participated in a reserved bidding process. And here he mentioned that $42.5 per megawatt hour should be charged whenever ISO can make use reserved power. And similarly, two more loads or two more customers C1 and C2 and who also participated in reserve process, and customer C1 can represented to cut back 15 megawatts during reserve process for $55 per megawatt hour, and customer C2 can cut back their 10 megawatts for $70 per megawatt hour whenever reserve power is utilized. So, and accordingly, let us consider ISO can anticipate that it will need a large operating reserve. Let us assume 55 megawatts. So that's why here one hydro generator, electric generator, that is 30 megawatts and 15 megawatts from C1 and 10 megawatts from C2. Altogether, ISO think that 55 megawatts is required for maintaining operating reserve. And accordingly, let us see this picture, supply and demand curves of initial situation at 1 p.m. So in the next day, after taking agreement with, after considering 55 megawatts as reserved power, then in the next day, let us consider at 1 p.m. Both supply and demand is balanced. So which is demand is a vertical line and supply is a variable one. So and the meeting point or the intersecting point of both these demand and supply curves gives market clearing price, and in this picture it is representing $35 per megawatt hour, and demand is 230 megawatts. Let us see next, and spot price is spot price of the electricity at this point is $4. So, and thus whatever the generators involved in this situation is arranged in this like this. So 10 megawatts, so pile of generators are arranged in a vertical way here. So production, total production is 230 megawatts, and if you see different generator can charge. One generator is bottom, the generator who is charged is preferred initially, so that is $10 per megawatt hour. 15 next generator is charged $15 per megawatt hour, and next generator, that means after 100 megawatts, in between 100 to 150 megawatts, that means 50 megawatts is provided by one generator and who is charging $20 per megawatt hour. And similarly, next 50 megawatts is charged by $25 per megawatt hour. And next 30 megawatts is charged with $35 per megawatt hour. Like that, total production is here. And suppose if $20 per megawatt hour, so let us consider that due to generator outage, 50 megawatts is not possible to get into the market. That means from 100 to 150 megawatts, 50 megawatts is available and who is charging $20 per megawatt hour. And due to his generator outage, who is unable to give 50 megawatts. At that time, definitely mismatch between generation and demand will be takes place. Let us see this. So 50 megawatts was outaged, and hence there is a mismatch between generation and demand. So supply curve and demand curve are not intersecting. Hence, whenever generator outages takes place and there is a scope to rise, there is a scope to rise prices for electricity for the other generators. So that's why here ISO should immediately bring the balance between generation and demand. That is the foremost objective of the ISO. And that's why ISO can think about what are the reserve, what is the reserve available with that ISO. So initially you have a generation 30 megawatts generation available. So that's why he brought so whatever this picture. So the total production is 180 only. Earlier, total demand and generation is 230 megawatts, and due to generator outage, 50 megawatts was not available, and hence only 180 megawatts is available, and demand is 230. So that is pictorially represented. So there is a mismatch between demand and generation. And now generator immediately brought into immediately dispatches 30 megawatts generator uh, who is in reserved capacity. So when you brought 30 megawatts immediately, then total supply here is 180 plus 30, which gives 210 megawatts. But our demand is 220 megawatts. Still, there is a mismatch. Supply shortage is 20 megawatts. So that's why ISO should immediately. So you just see at 1:10 p.m. Balance between supply and demand was not possible due to generator outage, and immediately within 4 to 5 minutes ISO brought 30 megawatts and total generation is 210, and still shortage is there. Then ISO think to bring both the loads who are participated in the operating reserve, and they are 20 megawatts. So you just see this one. Yes, so 20 megawatts gap is available. So that's why that to restore the balance, the ISO also dispatches off 15 megawatts. That means customer C1 can cut back his unwanted loads, and such that he can provide 15 megawatts. He can set down 15 megawatts, and similarly customer C2 can set down few loads and having capacity 10 megawatts, and accordingly the demand will be come back to the 210. Why? Because total supply, available supply is only 210, and ISO doesn't have any capacity to improve the generation, and at that time ISO can make use customer C1 and C2, and such that customer C1 and C2 they can cut down their generation, and hence balance will be possible. So that is 210 megawatts. So like this ISO can maintain balance between generation and demand by making use operating reserve. But you should understand here, yeah, just see here, after bringing 30 megawatts capacity, at the time generator is charging for 30 megawatts, hydro generator is charging $42.5 per megawatt hour. So generally, before generator outage, spot price is only $35 per megawatt hour. But due to shortage of generation, and when ISO make use what you call hydro generator, then he will charge more price like $42.5. So similarly, if you just see here, C1 and C2, they can cut back their power from 15 megawatts. C1 is 15 megawatts and C2 is 10 megawatts, and accordingly they can charge. C1 is charging $55 per megawatt hour, and C2 is charging $70 per megawatt hour. Like that, they can charge who are participated in operating reserve, and like this ISO can maintain balance between supply and demand. So next one is power exchange. So power exchange is also quite similar functionality with respect to the ISO, and who is also non-profitable and independent entity. And even though short-term and long-term financial energy transactions could be in the bilateral forms in the electricity industry, where contacted parties agree individually for certain terms such as price, availability, and quality of products. Industry restructuring proposals have concluded the necessity of creating new marketplace to trade energy and other services in a competitive manner. So this market is termed as power exchange and sometimes called spot price pool. And this marketplace permits different participants to sell and buy energy and other services in a competitive way based on quantity, bids, and prices. So generally, large customers only make use power exchange concept. So participants include utilities, power marketers, brokers, load generators, retailers, large industrial customers, and co-generators. So PX is a new independent non-government and non-profit entity, as I said earlier. So which is non-profit and independent entity, and which accepts schedules for loads and generation resources. And it provides a competitive marketplace by running an electronic auction where market participants buy and sell electricity and can do business quickly and easily. So through auction, PX establishes market clearing price for each hour for the following day for traders between buyers and sellers. So in this marketplace, PX does not deal with small consumers. So that's why ISO PS only used by large consumers, and when you require both small and large consumers coordination, then we go for ISO, and sometimes for improving competitive levels among the large consumers, then they can make use marketplace as power exchange. And here PX manages settlement and credit arrangements for scheduling and balancing of loads and generation resources. It is claimed that participants entering the PX get more competitiveness by removing the complexities of arranging generation, transmit, day-ahead market and ahead market. So one more is market clearing price. So PX accepts supply and demand bids to determine a market clearing price for each other 24 hours in the trading day. Computers aggregate all valid supply bids and demand bids into an energy supply curve and an energy demand curve. So meeting point of these two curves gives MCP, and MCP is the balance price at the market equal to for the aggregated supply and demand gaps. Generators are encouraged to bid according to their operating cost because bidding lower would lead to financial losses. So, based on their operational expenses and cost, generator should bid their selling process. And similarly, if MCP is lower than the operating cost, bidding higher could cause units to run less frequently or not run at all. So that means if generators bid too low is also not economical, and which will be gives losses for the generators. And even bidding too high prices is also not good. Why? Because sometimes may not be run at all. Generators may not be run at all. So that's why generators should see the market conditions, and they can accordingly bid the prices for their quantity of power. So next important concept is market operations. So day ahead and hour ahead markets. So day ahead market, nothing but for each hour of the 24 hours scheduling day, sellers bid a schedule of supply at various prices and buyers bid a schedule of demand at various prices. And MCP is determined for each hour. So that means sellers and buyers both can bid their prices for their energy before one day for each and every hour, and market clearing price will be determined for each hour from the ISO or power exchange. So PX schedules supply and demand with the ISO for delivery. Supply and demand are adjusted to account for congestion and ancillary services then PX finalizes the schedules. So once the MP is determined in the PX market, so one more important point is the hourly market is similar to day ahead, except trades are for 1 hour and available transfer capability is reduced to include day ahead trades, and bids are not iterative in this market. So MCP is once MPC market clearing price is determined in the PX, market participants submit additional data to the PX, and the data would include individual schedules by the generating units, takeout points for demand, adjustment bids for congestion management, and auxiliary services bids. So after this stage, ISO and the PX know the injection points of individual generating units to the transmission system. The schedule may be included import or export the power. So ISO and PX can inject points for individual generating units to the transmission system. So you should next one is elastic and inelastic markets. So if you see the vertically integrated power system, that is few decades back we have vertically integrated power system, which is inelastic demand curves. So in which demand is inelastic, and but due to the restructuring process, demand should be considered as elastic such that benefits will be considered. So an inelastic markets does not provide sufficient signals or incentives to a customer to adjust its demand in response to the price. So that means whether the customer can increase the demand or decrease the demand, he doesn't get any incentives. He doesn't get any incentives for adjusting his demand based on the price signals. So that is called as inelastic market. And the customers does not have any motivation to adjust the demand for electrical energy. So in a market that has a demand, MCP for energy is determined by the price structure of supply side. The concept of inelastic demand is directly related to the concept of free load, which formed the basis of the electricity industry for many decades before the introduction of the open access and energy. That is nothing but vertically integrated system. So customers use the concept of elastic demand when they are exposed to and aware of the price of energy and arrange their affairs in such a fashion to reduce their demand as the price of the next available offers exceeds certain levels. So you just see here, this pictorial representation shows that vertical curve represents demand curve, and variable curves, one is thick line and one more is dotted line. So that is supply curves 1 and 2. So whether supply curve, so that means so whenever supply is changed or increased, so based on the demand, so they are charging same. That means you just see here initially supply curve 1, so which is they are charging $35 per megawatt hour, and when supply reduces to second curve, then they are charging market spot price is $27.5 per megawatt hour. So that means supply comes down and its price also comes down, but still, so whether price is low or high, demand is not possible to change. That means the demand curve is not an elastic future, so which is not an elastic future. Suppose if you make demand is electricity, so you just see here supply curve is charging, supply curve 1 is charging, so that is $35, near to $35, but in the previous case, so supply curve 1 and supply curve 2, demand is not changing, and when supply is changed from $27.5 to $35, then demand will change. That means if demand can have an elastic nature, then they can change the consumption pattern during when the market charging high prices. And similarly, a market that has an inelastic demand operates normally as long as supply offers exceed the current demand. See, when supply is more And suppose if you consider inelastic demand and supply is elastic, but no issue. Why? Because supply is more than the demand, then we don't have a problem. But whenever uh, supply shortfall is there with respect to the demand, then inelastic demand curve will be difficult. So that means demand will not able to get power due to shortage of supply. That's why if the demand curve have the flexibility, elasticity nature, then based on the supply, available supply, the demand can also change its consumption pattern and such that he will be benefited and he will get continuous supply. However, so that's what here it is presented. So you just see this. The problem of restoring the balance between supply and demand is much easier when the demand is elasticity. From this example, it is observed that elasticity in demand is beneficial in keeping the MCP lower also. So here, if the demand curve has the elasticity nature, then customer will be charged low, and as well as customer will be able to get power continuously for critical loads at least. So one more important challenge in restructured power system is market power. So market power is nothing but which is an anti-competitive practice which is generally used by dominant generators, sometimes intentionally and sometimes accidentally. So, market power may be defined as owning the ability by a seller or a group of sellers to drive price over a competitive level. See, over a competitive level. So, generally, market want to improve the competitive level, but here market practice is a anti-competitive practice, such that some dominant generators or people or customers can drive the price over a competitive level. So which is not good, and the net result of practicing market power is a transfer of wealth from buyers to sellers or a misallocation of resources, and such that if people generally use market power intentionally, then business in the country or the society will not be developed. Why? Because they will be part of the revenue will be compensated to the electrical charges. So that's why we always try to keep market electrical charges as low as possible, and such that more number of business activities will be comes into picture, and such that globally society will be developed. So market power is exercised either intentionally or accidentally. So, for example, in the generator sector, market power can be exercised by having an excessive amount of generation in the relevant market intentionally. So, whoever have excessive generation, then definitely intentionally they can practice market power. And sometimes accidentally they can practice market power whenever transmission constraints arises. So, like that, we have two types of markets. One is vertically market power, and one more is horizontal market power. And vertical market power should make use bottleneck process. So that means, so based on transmission constraints, people used to raise the prices for electricity charges, such that which is sometimes dominant providers can practice market power whenever transmission constraints arises. So a control of the bottleneck process enables the firm to give preference to itself or its affiliate over competitive firms. That means here transmission owners can, as I said earlier, transmission owners can share information, critical information to the affiliated organizations or entities, and they can hide some critical information to the other people, customers, such that they can raise the prices. So, which is not quite good for healthy market. So, and successful development of well-planned and fully functional ISO may resolve vertical market power problems. And next one is horizontal market power. It is the ability of a dominant firm or group of firms to control production or restrict output and thereby raise prices. So that means if such concentration is sufficient with respect to the certain other market conditions, the PIM can influence the supply-demand equilibrium. Suppose I will discuss how transmission constraints, whenever transmission constraints arises, how people used to practice market power, and similarly, I will choose one example to describe how dominant generators can practice market power. Let us see, and this is market measuring market power. So we can measure market power. So based on this equation, Herfindahl-Hirschman index, we can measure the concentration of market power, and it is defined as the sum of the squares of market squares sales of all participants. So let us consider one example such that we can understand better. So let us consider three generators. Generator 1 is having capacity to generate 120 megawatts. Generator 2 is having capacity to generate 250 megawatts, and generator 3 is having capacity to generate 600 megawatts. 600 megawatts. So, and total load is 600 megawatt, and load is connected at bus 3, and so load is total load is 600 megawatts. And here generator 1 is able to generate 120 megawatts with $8. So among three generators, generator 1 is charging less, and generator 2 is charging $14, and who is able to provide 250 megawatts, and generator 3 is able to provide 630 megawatts, and who is charging $23 per megawatt. See what is the difference with generator 3 and other two generators. So who used to, why? Because he is a dominant generator. How he became able to catch the point. So total load is 60, and available generation is 120 megawatts from generator 1, and from generator 2, he can able to provide only 150 megawatts. Why? Because here you just see the transmission constraints. From bus 2 and bus 3, it is 140 megawatts maximum you can transfer, and from bus 1 and bus 2, bus 3, you can transfer only 130 megawatts. So like that, altogether, total available generation from generation 1 and generator 2 is 370 megawatts. But you can, due to transmission concerns, you can able to provide only 130 plus 140, that is 270. So actually we have 370 megawatts, but from generator 1 and generator 2, but we are producing, or we are sending only 270 megawatts, which is why? Because transmission constraints are there between. So now generator 3 have due to his dominance. So other 330 megawatts should be borrowed from only generator 3. So that's why generator 3 is a dominant generator in this case, and he used to improve the price as $23 per megawatt. So here due to excessive generation, he can able to improve. Suppose if we have around only 300 megawatts, in this case, generator 3 is having only 300 megawatts, and generator and transmission limits are not there, then definitely generator 3 will not improve price like $23. Why? Because he is not a dominant generator, but he is in this present example, he is a dominant generator, and load L3 doesn't have any alternative. He definitely borrow power from only generator 3. That's why this fellow generator 3 can act as a dominant generator, and he used to improve the price. And similarly, we calculated all this. And similarly, let us take one more example here. Generator 1 is producing 250 megawatts, generator 2 is producing 350 megawatts, and generator 3 is producing 400 megawatts. But if you see the transmission line constraints, from 1 to 3 it is 100 megawatts, from 2 to 3 it is only 100 megawatts, and we have load at generator load at bus 3 is 600 megawatts. So that means due to transmission line limits, generator 1 and generator 2, they can send only 200 megawatts altogether, and the rest of the 400 megawatts must be taken from only the generator 3. That's why once again he can try to practice market power due to the transmission limits. But if you see generator 1 and generator 2, both the capacities of generator 1 and generator 2, if you consider, it is around 600 megawatts. So by excluding generator 3, generator 2 and generator 2 can be able to provide power to the load 3. But here, due to the transmission constraints, load 3 doesn't have any alternative, and that's why this generator 3 can act as dominant generator, and due to the transmission constraints, he can catch the issue situation and he can practice the market power. So like this, and that's why he is charging $30 per megawatt. So like this, market power is a great challenge to be resolved in the restructured power systems. But if with rules, if proper rules and regulations and some measures, definitely we can resolve this issue. And the next one is congestion pricing. So before going to the, so what is congestion? Congestion is nothing but overloading transmission lines or transformers is nothing but congestion. So congestion could prevent system operators from dispatching additional power from a specific generator. So congestion could be caused for various reasons such as transmission line outages, generator outages, change in energy demand, and uncoordinated transactions. So congestion may result in preventing new contacts. So whenever congestion takes place in a transmission line, then definitely it is not possible to do more number of contacts with respect to the customers. Why? Because you don't have transmission capacity to transfer electrical energy, and infeasibility in existing and new contacts, additional outages. So if you're not able to handle the congestion properly, definitely additional outages will also prevail. So monopoly of prices will also prevail. So and hence there is a chance to damage in the power system. So that's why congestion is also one of the important challenge in the restructured power system, and you should be able to take a congestion and you should be able to handle congestion seriously, and you can always try to eliminate congestion in a short span of time, such that additional outages will be avoided and monopolism with respect to the prices will be avoided, and of course damages in power system will also be avoided. So a fast relief of congestion may be possible by removing congested lines to prevent severe damages to the system. So before the later solution takes place and its consequences on existing contacts to be studied. And so if you see our vertically integrated power system, congestion costs were either ignored or hidden as bundled into the transmission charges. Why? Because all generation, transmission, and distribution charges are made by one entity. That's why even congestion charges are also ignored sometimes, or they may be hidden in the transmission charges. So that is not a true price signal for the customer. So that is one of the shortcomings of vertically integrated system also, in fact. So to manage congestion, transmission congestion, we mainly initially establish rules for managing the market conditions and preventing congestion from developing. So FERC, Federal Energy Regulation Commission, suggests that market that are based on LMP and financial rights for firm transmission service will provide an efficient congestion management framework, and this due to the following facts. So LMP, locational marginal price, assigns congestion charges directly to the transmission customers in a fashion that agrees with each customer's actual use of the system and actual dispatch that its transaction costs. So similarly, so that means LMP charges nothing but congestion charges which are assigned in the transmission customers in a fashion that each customer actual use of the system and the actual dispatch that its transaction costs. So LMP facilitates the creation of financial transmission rights which enable customers to pay known transmission rates and to hedge against congestion charges. So with these two, so congestion charges are paid to the transmission customers. So here we have three methods to charge congestion. So one is cost out of merit dispatch. So in this method, congestion costs are allocated to the each load on the transmission system based on its load ratio share. So based on its actual load. So that means congestion costs are allocated to each load based on its actual load, the total load. So one more is based on locational marginal price. So based on the locational marginal price is nothing but cost of supplying energy to the next increment of load at a specific location on the transmission grid. That means it determines the price that buyers should pay for energy in a competitive market at specific locations and measures congestion cost by considering the difference in LMPs between two locations. So in between two locations, the difference of LMPs is nothing but charge made to the customers. And next one is uses charges in charges of interzonal lines. In this approach, ISO region is divided into congestion zones based on the historical behavior of constrained transmission path. All transmission users who use the interzonal pay use charges. So like this, three different ways are used for pricing, for charging congestion. And transfer capability issues. See, for improving competition in the any market, especially in electricity market, transfer capability issues should be addressed effectively. Then only competition will be improved in the system. So the transfer capability is usually calculated based on offline computer load flow simulations of the interconnected transmission network under a specific set of assumed operating conditions. So while calculating load flow simulations, you should consider several factors such as during completions, you should consider projected customer demands, generation demand, dispatch, system configuration, base case schedule transfers, and contingency cases that reflect the degree of required system security. And not only this, uncertainties facing of operation of interconnected electric power systems are generally due to the weather conditions, forced and scheduled transmission outages, generation availability and unavailability, and future location of demand and electricity resources. So you should consider all these things while calculating transfer capabilities in the transmission system. So as time passes, electric power systems will be more complicated. Definitely, power system will be more complicated since more number of participants are coming into the picture and more number of uncertainties will be arises due to the more number of participants and their activities, and it is little difficult to estimate total transfer capability and available transfer capability, and all, which is also very difficult to estimate TTC and ATC. So that means when projections for transmission capabilities are made for longer time horizons, the degree of uncertainty is presumed conditions and the degree of uncertainty in transfer capabilities will grow. So due to more number of aspirant participants and as well as customers are involved in the market, and definitely due to the more number of population, demand is also increases such that more number of uncertainties will also increases, and hence it is little difficult to estimate transfer capabilities like especially total transfer capability and available transfer capabilities. And definitely which if uncertainties are not managed properly, an unreliable operation of electric power system could be prevailed. So that's why it is important to address transfer capabilities is effectively. So one is ATC, available transfer capability, is a measure of transfer capability remaining in the physical transmission network for further commercial activity over and above already committed users. Apart from the committed agreements and committed uses, what is the remaining available transfer capacity in a transmission network? That one is nothing but ATC, and which is evaluated based on various things like total transfer capability and transmission reliability margin, and existing transmission commitments, including customer services between the same 2 points and capacity benefit margins. So we will see one by one. Total transfer capability. So we should calculate, so for calculating ATC, you should calculate TTC, TRM and ETC and as well as CBM. So total transfer capability is the amount of electric power that can be transferred from one area to another over the interconnected transmission network in a reliable manner based on pre-contingency and post-contingency conditions. So TTC is constrained by thermal voltage and as well as stability limits. So for calculating TTC, you should always consider minimum thermal voltage and stability limits. So you just consider thermal voltage stability limits are minimum, and based on those limits, we can able to calculate total transfer capability. So TTC is calculated, of course, hourly, daily, and as well as monthly based on market requirements. Certain factors should be taken into account in TTC calculations, such as the list of contingencies that would be retained. So for calculating TTC, you supposed to consider list of possible contingencies, and you can expose each and every contingency, and you can calculate TTC. And among all these contingencies, what is the minimum TTC appeared for all different contingencies, and that is considered as total transfer capability. So the definitions also imply that TTC and ATC values are time dependent, and as the time transmission system conditions would change over time, which means that the calculation of TTC and in turn ATC would need to be updated continuously to reflect changes in system conditions. So let us here, this is nothing but a small algorithm how to calculate TTC. So starting from the current operating point to the base case, load and sink bus should gradually be increased, and the corresponding load flow would be calculated, while the source bus acts as swing bus. If any of thermal voltage stability constraints is reached, the corresponding power transfer from the source to the sink becomes the total transfer capability candidate. So like this procedure should be adopted for all possible contingencies, and at the final TTC for the sourcing pay at the base operating point is minimum TTC of all the TTC candidates. So that means you're supposed to calculate TTC candidate for all possible contingencies. Among all possible contingencies, what is the minimum TTC candidate? And that is considered as final TTC for that particular system. Like that, you can calculate total transmission capability. And next one is transmission reliability calculation. So not only for transmission system, for every system, you should keep certain margin. So like that, suppose you just consider a small example. We have national highways, right? So one way and two way, and they also on the roads they also marked white paint at the one side, and go for at one side of the road for moving small vehicles like bikes and cycles, and for walking people. They divided the road, and they provided small space for passage of motor vehicles. So that means if all vehicles move in the middle of the road, there is a chance to traffic jams, nothing but congestion. There is a chance to collide vehicles, that is nothing but accidents. And similarly, here also, due to congestion, unwanted consequences will be takes place in the transmission system. and that means transmission line outages like that. So that means some margin for every concept will be created, and similarly here also analogous to the roads, you should create some margin for maintaining reliability and for inherent uncertainties in the interconnected power systems. So TRM is defined as the amount of transfer capability necessary to provide a reasonable level of assurance that the interconnected transmission network will be secure. The TRM accounts for the inherent uncertainties in the system conditions. It associated effects on ATC calculates and the need for operating flexibility to ensure reliable system operation as system conditions. So to meet the inherent uncertainties in the interconnected power systems, we need to maintain some margin that is called as transmission reliability margin. And one more margin is capacity benefit margin, and it is defined as the amount of wind transfer capability reserved for load serving entities on the host transmission system where the loads is located. So that means for transmission systems also certain loads are there. So for those loads also you supposed to provide some amount of capacity. So that is called as capacity benefit margin. And to enable the access to the generation from interconnected systems to meet generation reliability requirements. So, so far we discussed what we call transmission capability issues, and now let us already we talked a few times about electricity price, and of course it is in restructured power system definitely electricity price is volatile. So that means varying nature. So what are the reasons why electricity price is volatile? So if you see this pictorial graph, so which is taken between January to March of a spot price in a market, then it is having little cyclic nature, and of course it is a non-homogeneous nature also. So compared to non-energy commodities, electricity price is the most volatile. So practicing market power. So what are the reasons? So whenever people practice market power in the market, then they can drive the over competitive levels. Then there is a change in price, spot price, and in only that one. So one is load forecasting error. And whenever people not forecast properly, then misrepresentation will be takes place. Hence, demand and load will be imbalanced, and that's why people try to increase the spot price. And in response to this problem, different techniques have been proposed, which include limiting the ownership of dominant generators. In order to reduce price volatility in the energy market, a trading system may allow customer to sell energy back through the trading system in certain hours. That means, suppose generator means not on customer means not only can purchase electrical energy whenever electrical energy charges are less, and sometimes the same customer can also resell back to the market when the electricity price is more. So that means due to varying nature of the electricity price, customers can do trading business in the market such that they will not be affected. Otherwise, if they purchase electricity and the prices are increases, then they have to pay more money, and that is not feasible for running his entity or business activities. So that's why there is a feasibility to trade back the electricity when the prices are high is also possible in this restructured system. So let us understand what are the various reasons or factors which affects electricity price as volatility. So one is load uncertainty. So the power generation required to meet the load is directly correlated with the weather conditions. So load uncertainty. So when forecasting load, you should be able to consider weather conditions properly. And if you're not able to consider weather forecast properly, then there is a scope to mismatch, and there is a scope to forecasting errors with respect to load also. So, and not only that one load uncertainty, one more is fuel prices. The fuel used by the generating units to produce electricity is a volatile commodity with its price depending on market conditions such as demand supply convergence conditions. So that is transportation, storage expenses, and other factors. That means suppose if you use coal for producing electrical energy, so you should suppose to purchase coal and you should bring that coal from one place to the required place, and you could store in that place, and you can make use that coal from storage location to the plant location. And for all these things, you're supposed to spend some money for doing all these activities. That means fuel price is also varying. So that's why nowadays renewable energies also comes into picture for due to the depletion of the fossil fuels like coal, nuclear, etc. Renewable energy generation, the renewable generations comes into picture. And anyway, that is let us discuss various factors which affect volatility. So, in addition to the load uncertainty, fuel prices is also one of the reasons why the electricity price is volatile. And in some locations, people use hydroelectricity production whenever huge rainfall is available, and the rest of the time they can make use coal as a coal generation. So that's why electricity price will be varied from one concept to the other concept. So that means when you see hydroelectricity, which is depending on rainfall, so whenever rainfall is more, then we can make use, and such that at that time definitely cost of electricity is a little less when compared to when we supply coal energy based on coal. And next one is unplanned outages. So that means imbalance between supply and demand could cause large fluctuations in prices. So when supply is less than the demand, or when demand is changing rapidly, price spikes would arise. And when this is accommodated by a generating outage at peak hours, price spikes could be very high. So as I discussed in the earlier operating reserve case, where due to sudden outage of 50 megawatts capacity, who is charging $20 per megawatt hour, suddenly misbalance between generation and demand takes place, and ISO should take responsibility to maintain balance between generation and demand by making use the operating reserve, such that at the time prices will be rises. And if ISO is not available, then definitely price cap is not possible. So that means price will be raised abnormally and rapidly. So that's why price cap is essential, and that will be possible with the help of ISO. So anyway, so unplanned outage is also one of the reason for volatility nature with respect to the electricity. And a few more are nothing but transmission, constrained transmission. So so whenever transmission, already we discussed one example with respect to the congestion, or with respect to the transmission. So limits, whenever transmission limit is reached, and even though we have sufficient generation, but due to the transmission limits, we are unable to send generation to the load, such that the other people who are able to generate supply electricity to the load will practice market power. So like that also price will be varying. So that is also one of the reasons why the electricity price is volatile. And one more is market power. So already discussed, dominant generators can practice market power sometimes accidentally and sometimes incidentally. And accidentally they can practice whenever transmission limits comes into picture. And last one is market participant. So sometimes market participants themselves may cause price volatility by misrepresenting the actual amount of their loads, like under scheduled or over scheduled loads. That's why variation with respect to demand will be changes, and they can rise the prices. So these are the various reasons why the electricity price is volatile nature. And power system operation in competitive markets. So already it is 1 hour. So far I took 1 hour 30 minutes. So that's why I will skip a few slides which are not important, and I will highlight only important slides. So as it is mentioned, so power system operation in competitive. So as it is mentioned earlier, several players have emerged in the deregulated electricity market, Consequently, many of the activities of system operation have been taken over by different entities. So why? Because generators, transmitters, transmission and distribution companies and consumers, and as well as retailers and some people who used to do business with some people, they don't have generation, they don't have transmission, they don't have load, but they can do some business with electricity markets. So, like that, many people are involved in the power system competitive market. Hence, coordination between their activities is to be maintained for system security and reliability. Hence, the independent system operator is the central entity to have emerged in all derivative markets with the responsibility to of ensuring system security and reliability and fair and equitable transmission tariffs and providing for other transmission system services. So, in any market structure, it is a pool or bilateral contract dominated one. The ISO has three basic functions. So, one is maintenance of system security and reliability, service quality and assurance, and promotion of economic efficiency and quality. These are three foremost objectives of the ISO for maintaining good competition in the transmission system. Good competition in the power system, and such that customers will be getting uninterrupted power supply and reliable supply with a reasonable cost. And to achieve these objectives, the ISO may be authorized to set the rules for transactions between suppliers and consumers, scheduling and dispatch of generators, loads and network services, and energy. So, how ISO will be behaves in pool markets and as well as in bilateral markets. And so, let us discuss ISO in pool markets. So, in deregulated electric power systems operating with pool type of structure, ISO is responsible for carrying out market activities such as reserving bids for suppliers, unit commitment, and dispatch simulations for GENCOs and setting up the market clearing price. And it also has the responsibility for ensuring system security and undertaking congestion management, for which it has to procure ancillary services. So ISO is full responsible for scheduling, for bidding, scheduling, and as well as dispatching power and supporting ancillary services to the required customers. And if you take time scale, on a time scale starting from 1 day ahead of actual operation of real-time operation, ISO activities in a pool can be classified as carries out a load forecast, determine the aggregate and the bids can be of different types, and many sometimes also include information of unit commitments such as startup, set down, ramp rate limits, and associated costs. Based on this information, it simulates the hourly dispatch. So ISO should generate hourly dispatch and evaluate the system prices for each hour of the next day. And that's what here it is given. So in real time, dispatches, generation, and load. So procedures and providers system services such as reactive power support frequency. So during real time, not only dispatching generation to the load, and ISO should also able to procure ancillary services for customers whoever required. And after real time, ISO should settle accounts with respect to customers like generators, consumers, and as well as transmission customers, etc. And two types of market settlements have been proposed for the adoption of market operation. One is maximization of social welfare, and one more is minimization of consumer payment. So the first objective effectively minimizes the total cost due to the assumption that the generation bids correspond to the actual cost. So which is nothing but double action power pools. Anyway, let us see social welfare maximizing market settlement. So maximization of a social welfare objective function to obtain the optimum dispatch schedules has been the common practice in most centralized power pools. Two cases may arise in this class of problems. One where the market operator receives both supply and demand bids, and the system price is obtained by matching the highest price sell bid to the lowest price buy bid. So which is nothing but double auction power plants. And the other way, only supply bids are received and the system price is obtained by finding the highest price bid intersecting the system demand forecast. So that is nothing but single action power plant. So one is double action and one more is single action. So in case of double action power plant, system price is obtained by stacking the supply bids in increasing order of prices. So the generator who is charged less queues get more preference and later like that based on increasing of the prices, you can stagnate all the supply bids, and similarly, the demand bids is in decreasing order of the prices. So whoever got highest in the bids, he will get more preference. That's why he considered first. Unlike that, whoever is charging least and he is coming at last. And sometimes he may not get power from the market also. Too low for buyers buying electricity is not good. So based on market conditions, you're supposed to bid with respect to the electricity prices. Like that, supplier bids and as well as buyer bids should be arranged in increasing and decreasing order, and such that the meeting point gives market clearing price. The meeting point of both the curves gives market power. And the area under these two areas, so here in this picture, the green color area is represented social what you call welfare what you call social welfare maximizing system. So that means the system price and the amount of energy cleared for trading is obtained from the crossing point of these two curves. And the shaded area in the figure denotes the social welfare from market-based operation that the market operators seeks to maximize. That means if this area is increased, that means more number of participants are involved in the market process for selling and purchasing electricity, such that more business activities will be takes place. That means whenever if a system, whenever a customer have a business activity, and for that he required electricity, so then only he will join in that. So that means if this area is more, that means more number of people across the society dealing with many different business activities, such that our society will be developed. But in terms of employability with respect to other opportunities, and with respect to electricity market. That means if more now business activities are taking place, then those people will be involved. So that means if power is reasonably provided to the customers, then they will think to start more business activities, such that amount circulation with respect to the business activities will be possible in the society, and such that in terms of employability, in terms of production of products, and in terms of business activities will be improved, and such that more country will be developed. So that means that's why they named as social welfare maximization with respect to double action power. And similarly, single action power, that means here only supplier bids are stacked in increasing order like this, and demand is almost same. Whenever supply curve meets the demand, then that gives the market clearing price. And here the shaded area is refers social welfare, but the market operator seeks to minimize the system cost also. Then only that area will be improved. That area will be improved, and such that it represents more number of participants are included in the market, such that they are doing more business activities, such that state or country or society will be developed. So similarly, the ISO in bilateral markets. So here ISO role is little limited. Why? Because in bilateral market, as I said earlier, customers can directly negotiate with the consumers. So I don't want to discuss to this one. So next one is operational planning activities of GENCO. So not only ISO, GENCO operating planning, operational planning activities of GENCO is also required. So as a GENCO, they don't have they have only one objective to improve or to maximize its profit. And therefore, the GenCo's operational planning activities differ with the market structure in which it is operative. That means GenCo doesn't bother about balance between generation and demand. It is only thinking about to improve its profit. Why? Because maintaining balance between generation and demand is open query. So that means that responsibility should be taken by the ISO, and that is not the responsibility of the GenCo. But whereas in vertically integrated system, that is also responsibility of the GenCo. Now, due to restructuring market, that is not an objective. So producing electricity and selling with maximum profit is the only objective. So in pool markets, so GenCo are required to bid for energy supply and associate price to the market operator. So in some markets, the GenCos are also required to provide startup price offers, ramp rates, and minimum up and down times. The market operator in turn carries out a unit commitment to obtain the optimal dispatch and settlements of market and formulates the generation schedule. So before 24 hours, the operational planning activity of GenCo operate in a pool market can be outlined on the time domain as follows. So a price forecast is available or carried out to estimate the hourly market price for the next day. And based on its, so that means price forecast must be done by the GenCo. Based on that price forecast, he can bid the generation. Bidding strategy will be considered for bidding period of the next day. In real time, meet generation schedules as ordered by the ISO. So similarly, GenCo in bilateral markets, just go to and market forecast. So an important input to the decision market activities of the GenCo is a forecast, good forecast of the market prices. So price forecasting refers to the day ahead or a week ahead forecast of the price, particularly the price in the spot market or the short-term market. This is important because an accurate forecast of short-term market price helps GenCo to bid for power sell or buy appropriately and strategically, thereby providing higher returns. So if strategical bidding procedure is not adopted by the generator, then definitely his generator power will not be sold out, and hence he will get loss. So thus, good spot market price forecast helps set up profitable bilateral contracts. So unit commitment in deregulated environment. In a competitive environment, the GenCo in principle has no other objective but to produce electricity and sell it with maximum profit. So as long as the objective is profit, the unit commitment scheduling can be done as if all generation after fulfilling the bilateral contracts is sold in the spot market. That means, so in bilateral contracts, he made some contracts and he need to fulfill those contracts. And apart from, if generation have excess generation, and he can participate in the market in pooling arrangement also. So the scheduling models are generally based on price taking assumptions, which means that no participant can influence the spot market price individually. That means no single generator can influence the price individually. This is an ideal condition, and the market in such a case is known as perfectly competitive market. And sometimes due to transmission constraints and due to generator outages, due to transmission line outages, and due to variation of the demand, sometimes there is a scope to mismatch between generation and demand, such that people may practice market power, and there is sometimes price will be over competitive level also. And the GenCo operating in such markets often have a mix of customers. Part of their load is under directly bilateral contracts and the price are fixed every year. So why? Because they already made contracts and they made agreements individually by individual negotiation. So that's why price is known with respect to bilateral contracts. And secondly, the GenCo has an unrestricted option to participate in the spot market as a buyer or as a seller. It also needs to maintain certain amount of reserve generation at all hours to account the contingencies, load variation, and spot market price fluctuations. So in this framework, GENCO has to plan its operation for the next day and take decisions on the following key points. One is unit commitment schedule, trading level in spot market, operating strategy to choose. So that means GENCO must be always think to produce electricity and sell it as much as profitable. But GENCO should be follow certain rules like what are the contracts made in the bilateral market should be fulfilled, and excess generation will be supply will be sell in the market, or if he have shortage of generation for meeting bilateral contracts, then he can purchase electricity from the market also. Like that, he can maintain bilateral contract activities, and as well as if they have excess generation, they can sell in pooling arrangement. So like this, like this, GENCO can think and participate in the various based on various operational planning activities in the market. So you just see this mathematical equation: profit is equals to revenue from spot market sell plus bilateral market minus payment for spot market by unit operating cost, startup cost, and shutdown cost. So that gives profit. So, but not only maintaining. So objective is maintaining or maximizing as much as profitable. So improving profit is one of the objectives. But what are the constraints? So it's supposed to follow the constraint like demand supply balance. But demand supply balance is not the constraint with respect to the generator, and which is constraint with respect to the independent system operator. But in fact, only seeking a part of wholesale system demand for itself. That means what is the total demand and what is the total generation. So in the total generation, what is the amount of electricity sold to the ISO? That amount of electricity must be provided by the GENCO. And the rest of the thing, that means unit commitment is somewhat an open-ended constraint with no particular requirement of meeting the demand. So that means meeting the demand is not a constraint for the GENCO, but meeting the scheduled generation. What is the amount sold to the ISO must be made by the GENCO. And not only that one more is limit on power sale. So how much a generator can able to sell power? So based on its capacity of generation plus what is the total capacity he is supposed to purchase in the market. So that's why power sale is always less than or equal to generation plus what is the power generation plus power buyed in the power purchased in the market. And other constraints like Rampart constraints and thermal units minimum, all this. So like this, these are the operational planning activities of GENCO. So GENCO always think to generate energy and purchase sell energy with profitable rate by meeting certain constraints like fulfill the agreements in bilateral contracts and fulfill the energy sold with respect to the ISO and sell energy less than or equal to the total generated energy plus total purchased energy in the market and some other constraints like this. So these are the operational planning activities of what we call GENCO. So next important concept is open access same time information system. So far we discussed various concepts like different markets like poolco, bilateral, hybrid, and some non-profitable entities like ISO and power exchange, and different markets like elasticity and inelasticity, and as well as transmission congestion or transmission capability issues, and where we majorly spoken about what we call congestion and its charges, and as well as ATC and TTC, etc. And how a customer can understand price signals with respect to all these concepts, whatever we spoke so far. So which will be possible through VIASYS. So VIASYS is nothing but open access same time information system. So VIASYS displays information like interactions of transmission providers, nothing but transmission company and transmission customers who is required, who want to transfer electricity from transmission lines and request to sell and purchase transmission services. So as I said earlier, transmission capability issues plays vital role in providing or improving competition in the market. So why? Because whether what is the transmission capacity and whether transmission line is overloaded or underloaded, or is transmission line have capacity to transfer some more energy, like that. So all that information, minute to second information will be disseminated to the customers. And how that will be disseminated, the critical information like transmission capability issues, and as well as total generation, available generation, and as well as what is the total demand, and all generation demand, and as well as transmission issues, all these things, and of course ancillary services also, all these are disseminated to the customers. And how this will be disseminated to the customers means open access same time information system. So what is OASIS? OASIS is nothing but permits posting, viewing, uploading and downloading of transmission transfer capability in standardized protocols. The data posted on OASIS should certainly identify what service is available, which request was accepted, denied, interrupted or curtailed, permitting business decisions to be made from the OASIS driven information. So OASIS plays vital role in disseminating information, critical information like generation, demand, and transmission services issues, and as well as ancillary services. All are possible to communicate to the customers. Customers may be power providers and power consuming customers. Will be possible only OASIS. And OASIS permits its users to reserve capacity and transmission system, purchase auxiliary services, resell transmission services to the others, and purchase ancillary services from third-party suppliers. See, business aspirants can participate in the market and they can sell transmission, they can purchase transmission services, and they can resell transmission services, and they can purchase generation and they can resell generation into the market. Like that, business will be do effectively and in a competitive way will be possible only when we disseminate all this critical information to the customers effectively, and that will be possible only OASIS. So OASIS would strengthen the accountability of both TPs and TCs, transmission providers and transmission customers, and the standards were designed to prevent employees of a public utility or affiliated engaged. So here also transmission, critical information of the transmission system must be disseminated in a OASIS, and which avoids shortfall of that means some transmission companies, they can hide some critical information and they can share that critical information to the affiliated organizations, and they can not share to the other customer, and that problem will be eliminated with this OASIS. And that means fair and open access is possible through OASIS with respect to the critical information, especially transmission capabilities. And that's why what is the structure of OASIS? So for forming structure of OASIS, engineers thought to create two groups. One is what working group and the next one is how working group. And in what working group, what OASIS, the OASIS what working group was the working group that handled questions like what information should be posted on a OASIS node. The focus of this group was on questions like what information and services should transmission providers make available to transmission customers, and what transactions should buy transmission capacity or transmission service should take place. And similarly, how working group handle questions like how was OASIS going to be implemented. So what means what information, what services should be posted and do in the OASIS, and how means how we can handle the OASIS and how we can implement the OASIS. So similarly, commercial practice working group, so which is also independent and consent based, agreement based group whose members represented industry segments and took on the responsibility of proposing business solutions for Oasis in addition to those, in addition to other aspects of the transmission assess. So, how working group established the set of principles to design the Oasis. So that means non-discriminatory access to the information. So that means each and every customer should access same information whether the affiliated customers to the transmission system is available or not. But every customer must be able to access fair and open access to the information and seamless interoperability from a customer point of view, easy access, and that means open access of information from multiple providers and multiple Oasis nodes would be imply seamless interconnections and flexibility. Oasis nodes should have as much flexibility to use the existing communication system, support added functionality, or even be able to use entirely different functions over the long term. So that means flexibility. So for changing functionalities with respect to Oasis must be adaptable to each customer nodes. So similarly, expandability, sometimes due to increasing population, and we should be able to increase Oasis nodes such that expandability must be considered, and customer driven and affordability. So all these things are important for establishing a set of principles to design the Oasis and functions of Oasis. So as I already spoke, I already stated many times, displays of critical information like transmission services, ATC, TTC, angular services, etc. It must be simulated based on the user-friendly tool for supporting the operations of energy market. So a Oasis is a market of sub-networks called Oasis nodes, each that would provide access to the transmission services information by transmission customers. The computing hardware, software, and internal communication networks of Oasis must obey with federal energy regulation requirements. So standard internet tools are proposed to access and exchange the information through Oasis to make the system open to wide range of users. So by considering standard internet protocols, internet tools, and with FERC rules, Oasis disseminate information like transmission services, ATC, TTC, and ancillary services and generation total load to the various set of customers effectively through the Oasis. And so you just see this by making use internet structure of Oasis node consisting of transmission capacity and transmission products database, and which will be possible to disseminate to the transmission providers, transmission customers with the help of internet protocols, internet tools. And similarly, you just see here we have transmission system information network node, so which is also known as Oasis node. And here we have different Oasis nodes with the yellow color, which is represented. And similarly, transmission customers and transmission providers can directly interact with the transmission service information network, or through internet also they can interact through the transmission service information network. And of course, value-added providers is also included in this. So that means transmission customer can take information through the transmission service information network node, nothing but Oasis node, through value-added provider, or directly through the internet, or directly they can connect to the transmission information system node. Like that, we have architecture and functionality with respect to Oasis. So Oasis nodes have three basic interface between the node and the transmission customer, interface between nodes, that means node to node interface between the node and the transmission provider. So that's what it is pictorially represented in this figure. So architecture of Oasis node. So the Oasis node architecture requires the internet compatibility such that all Oasis nodes could support the use of internet tools, internet directory services, and internet communication protocols necessary to support access to the required information. So coming to this architecture of Oasis, so through internet only we can transmission provider can provide information in the Oasis, so servers. So Oasis servers maintaining database, and they are also maintaining firewall and interface and energy management system, and like that. So the database function is there. It stores records of ATC and transmission transaction data. While this searches of those records acts as a backup in case of system malfunction. So the energy management system is connected to the Oasis node to provide accurate ATC calculation in real time. So like this, we have architecture with respect to Oasis and posting of information. So this is, so whatever we spoke so far, like transmission services, transmission capability issues like ATC, TTC, and as well as service requirements like scheduling information and transmission information, and all these things will be posted in the Oasis. So that's what we are discussing. So that is available transmission capability, pricing information, and other transmission related communication, scheduling information must be posted on the Oasis such that each and every customer can be able to see and understand the pricing mechanism, available generation, available demand, and accordingly they can plan their business activities and their consumption activities such that they will be benefited. Otherwise, if we are unable to provide all this information to the customers, and definitely the system is nothing but vertical integrated system that we practiced few decades back. So information requirements and Oasis. Once again, transmission survey system information. Already we covered this one. Right, transfer capability and Oasis. So which is also covered. So last one is auxiliary service management. So what are the auxiliary services? So first of all, auxiliary service means all those activities on the interconnected grid that are necessary to support the transmission of power while maintaining reliable operation and ensuring required degree of quality and safety. That is called as auxiliary service management. And what are the various auxiliary services which we are regularly making use in the markets? Nothing but frequency regulation. That means regulation of frequency and tie-line power flows, and voltage and reactive power control, and ensuring system stability. And last one is maintenance of generation and transmission reserves, and many others. So different auxiliary services are discussed here. Due to shortage of time, already I taken 2 hours. So just you go through this one, you can easily understand. So frequency, so that means whenever generator outage or transmission line outage takes place, frequency generation balance between generation and demand will be possible. So that means balance between generation and demand will be imbalance between generation and demand will be takes place such that frequency dip will be takes place, such that immediately with the available result, the ISO should bring the whatever the possible ISO possible generation must be able to include in the market. It will be included with the help of result, and still if it is not possible, then by making use of reserve loads. So that means customers who have participated to cut back their loads in the reserve process, then they can use, and immediately that is called as primary frequency control. And secondary control means to get, that means you just see this one, and the system will operate at a new steady state frequency that is slightly less than the normal. This is commonly known as governor regulation action, or sometimes primary frequency control. To restore the system to the nominal frequency, the generation set point of the unit should be readjusted based on the new generation load balance. So in many instances in the US, so automatic generation control is used, and in some European countries, manual adjustment is one example with respect to operating result. So no need to discuss. And reactive power and voltage controls. So some whenever transmission congestion takes place, sometimes reactive power must be provided to the transmission lines for maintaining secured operation. So sometimes we can control the acceptable voltages. So that's why we should provide reactive power and voltage control services also. And sometimes black start capability service. That means a major breakdown of a power system is a contingency that is rare, but one that nevertheless does occur. So that's why we should be able to take care that issue also. That means what is the large generating company in the market, and if suppose that generator is outage, then the market should be able to withstand to maintain the or set back the balance between generation and demand in a possible short time. So these are the auxiliary services which we are used in restructured power systems. So here auxiliary service. So for auxiliary services also you can join in pooling process, in bidding process, and you can get revenue by purchasing auxiliary services and reselling back in the market when you are getting profits. So that is the importance of auxiliary services. And next, last one is transmission cost allocation methods. So which is also one of the important one. But due to shortage of time, just I want to give briefing about transmission cost and its methods. So transmission wheeling. What is wheeling? Is nothing but the transmission system and associated facilities of the transmission utility are used by some other entity or person for conveyance, and this transmission wheeling provides transmission path for the flow of electrical energy between seller and buyer. So wheeling is nothing but whenever a transmission path is provided for communicating electrical energy from one location to other location, and that is nothing but transmission wheeling. And with the increase in amount of energy transactions, the evaluation of transmission capacity used for the same is an important problem for system operator. So wheeling transactions have been categorized in 4 ways. One is bulk power wheeling, denotes power transactions between two fully regulated utilities using the network of a third utility. And next one is, power transactions between two fully regulated utilities will be possible through the third utility. That is called as bulk power wheeling. And customer wheeling, that is when an independent customer purchases power from a utility through the intervening network of another party. So a customer purchased power through the market and he can make use third utility for wheeling energy from that purchased area to the load center. So that is called as customer wheeling. Similarly, supplier wheeling is when an independent operator sells to a supply to a utility through a third network. Similarly, fourth type is nothing but an independent generator sells power to an independent customer through the wheeling network called supplier to customer wheeling. So these are the different types of mechanisms in the transmission system. The customers exit. And last one is transmission wheeling cost, which is evaluated by different methods. One is postage stamp method, contact path method, MW mail method, MBA and MBA mail methodologies. These are the available transmission wheeling cost mechanisms for transmission cost. So these are the reference books I referred to prepare these slides. Thank you very much. Now, if you have any questions, please ask me. I will try to clarify with my knowledge. Yes, Bhargav, Sudhir.
Sir, thank you, sir, for your valuable session. So,
Sir.
I request HOD, sir, carry on.
Can you please speak little louder? I am unable to listen your voice.
Sorry, sir.
Please speak. Yeah.
Yeah, participants, if you have any queries, please, the session is open for queries.
So if you don't have questions, means whatever I said you thoroughly understood, or in another way is you are not at all understand anything. So please
Sir,
ask some questions.
Sir, there is a query from the chat box, sir.
Yeah.
Sir, can you explain the
Sudhir, can
major-
you, Vinod, can you please speak little louder? Your voice is little low.
Yes, sir. Okay, sir. So there is a query from the chat box, sir.
Yeah.
Sir, can you explain the major constraints when enhancing ATC, sir? So this is the query posted by one of the participants, sir.
For enhancing ATC, right? They are
Yes,
asking.
sir. Yes, sir.
So for enhancing ATC, you can make use reactive power. I mean, you can make use FAC devices. So by using FAC devices, you can supply reactive power and you can enhance the ATC. And I will discuss that challenge in the next session. It is on 25th. I will discuss. So for any test case system, I chosen one test case system, and for that I am showing to improvement in ATC by making use FAC devices.
So
See,
I request, sir.
Yeah.
Carry on, sir. Carry on, sir. So I request the participants to post the queries in the chat box.
Even my mail ID is also given in the screen. You please see, you please take it, and you can write an email to that email ID. I will clarify later also.
Sir, good afternoon, sir. I have one query.
Yeah, good afternoon. Please tell me,
Yeah,
sir.
thank you, sir. Thank you, sir. It's very interesting topic actually. Very useful. All academicians, deregulation. This is an advanced topic. Detailed session, sir. Yours is a detailed session. Point to point, you have covered everything. First of all, I would like to thank you for your beautiful and great session, sir. Sir, I have one query regarding this. That is. Ancillary services, you mentioned ancillary services. In that,
Yes.
reactive power is one of the ancillary services, right? No?
Yes, sir.
Sir, how can we provide that reactive power as an ancillary service to the customers? When and there, any customer, if he wants reactive power as ancillary service to maintain stability in the system,
Yes.
how can we provide, sir? How that system can provide it?
Yeah. I will tell. So thanks for your question. Actually, for ancillary services also, people who are ability to supply ancillary services can participate in the bidding process in a competitive way, and they can sell their ancillary services. And whenever any customer require ancillary service, then he can participate in the bidding process, and he can quote for ancillary service based on the requirements. And accordingly, ISO independent system operator can take care that request, and he can dispatch the ancillary services from the people who are selling ancillary services. So that means here procuring ancillary services means through the market only, and which will be possible for, so that means the people who are ability to sell, the ability to supply ancillary services can also participate in the market, pooling market, and as well as people who require services, ancillary services, they can also participate in the market, and ISO can schedule and dispatches ancillary services based on competitive prices.
Thank you, sir. Sir, who are the sources of that ancillary service?
Ancillary services means one is you can provide what you call frequency regulation. So frequency so whenever generation and misbalance will be takes place with respect to generation and demand, then frequency dip will be happen, and that one should be improved. That means frequency deviations should be maintained. That means you should be able to make use operating reserve that means ISO should make use operating reserve and try to improve the balance between generation and demand such that it can able to maintain the frequency levels. So that is one way. And if
Thank
you
you.
take reactive power supply, so as I said earlier, one of the participants requested me to how to enhance ATC. So ATC will be enhanced by sometimes by providing reactive power through fact devices also. And I will discuss the same thing in the next session. So like that. So reactive power supply, voltage control, and as well as frequency regulation, and all these things are nothing but auxiliary services and should be taken by the ISO based on inputs from the customers for auxiliary services and for purchasing. And similarly, some people may request, some people may participate for selling auxiliary services. So in a competitive. Yes. So may I know your name?
Thank you,
And
sir.
so you please tell me your name and
Yeah,
college where
this
you
is
are
Dr.
working.
Verma from KL University, sir.
Thank you, sir.
Sir, I have one more query, sir. Please, it's not query, doubt.
Yeah, please.
Sir, are we following any transmission cost allocation methods in our country?
Yes, sir. Actually, I was not given in detail with respect to the transmission cost allocation methods. In the last slide, I just given one different possible transmission evaluation cost. One is postage stamp method. One more is contact path method, and few more are MW, MVA, and MVR mail methodologies. So, based on with the help of these methodologies, we can allocate transmission cost.
That's okay, sir. Are we following these methods in our country?
Yes, sir. We are following.
Thank you, sir. Thanks for your more informative and knowledgeable session, for your great delivery, sir, and patience delivery for continuous tours. Thank you very much.
Thank you.
Sir, one more query is there, sir.
Tell me,
sir. So, query from one of the participants. So,
please speak louder. Your voice is little low.
Okay, sir. So, measures required to maintain reliability in a recent power system, sir. Okay. So, they are asking what are the measures required to maintain reliability in recent power systems. So, this is the query. Yeah. Query from one of the participants, sir.
Yeah, fine. So, reliability, how we can maintain reliability means we should always maintain balance between generation and demand, and that one will be taken by the ISO. Otherwise, whenever suppose if you are unable to give the generation all the times, then customers will not feel satisfactory with respect to the electricity. So that means continuous supply must be provided to the customers. Why? Because in some business activities they have some critical loads, so they always expect continuous supply, uninterrupted supply. That will be possible. So that will be made possible by the ISO. Otherwise, reliability supply is not able to provide it to the customer. So that means a satisfactory level of the customer is not possible to meet. So which is very important to maintain system security and reliability with respect to the customer requirements. Yes.
So I request rest of the participants to post the queries in chat box.
So in the next session, I want to discuss key issues like congestion management, available transfer capability, and reliability aspects, etc.
So I request the Sudhir sir. Hello.
Yes.
to take over the session, sir.
Yeah, thank you, sir. Sir, can you just check is there any queries in YouTube also, sir?
Yes, sir.
Yes, sir.
Up to now, no queries from the YouTube, sir.
Vinod, your
Oh.
voice is too low. Please speak louder.
Sir, up to now, no queries in YouTube, sir.
Okay. Then, okay. I hope participants can understand. And I thank all the organizers, especially Sudhir, head of the department, who used to interact with me for sharing information. And
Sir,
I also thank
one
all
more
the
query.
participants. Yes, yes, please.
Sir, one more query just now arrived, sir.
Yeah, please.
So how to work on contingency factors in ISO design, sir? So this is a very first
How to work on?
from one of the participants.
Sorry?
How to work on contingency factors?
Contingency
How to work on
factors.
contingency factors in ISO design?
See, so based on it is little difficult to consider, but if any contingency takes place in a system, ISO should take care to rectify as early as possible. So before take care to rectify that contingency problem in the generation or in transmission or distribution. So ISO, the most important duty of ISO is to bring the reserved generation and try to maintain as possible as balance between generation and demand. And still, if available generation is not possible to maintain the balance between generation and demand, ISO should make use load customers who are participated in the reserve. That is one way ISO can maintain balance between generation and demand whenever any contingency takes place in the system. And then only after clearing the disturbance, immediately normal operating characteristics will be revived. So that is another way. If demand is elasticity in nature also, demand whenever any contingency or fault or generator outage or transmission outage takes place, line outage takes place, then shortage of electricity, based on the shortage of electricity, then definitely people used to raise the prices, and that's why unnecessary loads will be set down by the customers when the price signals are truly visible to the customers. So these are the two ways. Immediately we can take care the contingency issues, and once after clearing the contingency, the normal operating characteristics will be revived in the market.
Okay, sir. Thank you, sir. Sudhir, sir.
Sir, Vinod, sir, thank you, sir. Sir, good afternoon, sir.
Good afternoon.
Sir, thank you so much, sir, for your valuable, very pleasant presentation, sir. You have covered a very in detail explanation about the restructured power system, sir. We hope it will be like just awareness means like introduction kind of thing. But you have gone very deep and you have presented all the points, sir. I assure, on behalf of our participants, I assure you they will make use of this valuable delivery regarding this restructured power system, which focuses on different factors, and we are still waiting for your that is key issues in restructured power system, sir. And finally, I heartfully thank you for spending your valuable time, sir, and sharing most valuable. I can say like it is the heart-burning concept in power system, sir. Thank you so much, sir, for spending your valuable time. On behalf of management and from our department, I once again thank you so much. Thank you so much, sir.
Thank you, Sudhir, for giving me an opportunity to present and interact with all the participants. I frankly speaking, this is my first lecture as a resource person in the short-term training programs like this. So I'm grateful to you also for giving me the opportunity. And I thank all the participants for listening me patiently. And for the 2.5 hours. It's a long session. Thank you very much.
Thank you so much, sir. We will maintain this relationship, sir, with your help
Sure. Definitely.
for future activities also, sir.
Definitely, Sudhir. Thank you very much.
Participants, now you can take a short break, and sharp by 2 p.m. We will be having a session on integration of renewable sources by Professor Palani, sir. So please be there on time. So this complete STTP you can utilize as an extension for the first STTP. Please be there on time. Thank you. Thank you to one and all.
Thank you,
Thank you, sir.
Thank you. I'm waiting.